Hello and welcome to a video which is going to take you through what I describe as wonky moments questions from the new Mechanics A2 syllabus, the Maths A-level syllabus, the Mechanics paper. Yeah. Now, I think there's really two really nasty new topics. I call them new. They're 4 years old now, but there's two new topics in mechanics which are really very tricky. That's these wonky moments questions and the projectiles questions, and maybe variable acceleration, but I don't mind that actually. But all three of those topics actually, if you need more questions, go to the old M2 past papers. There's always a wonky moments question, there's always a projectiles question, and there's always a variable acceleration question there. And they're exactly the same style as these kinds of questions. So, without further ado, let's take a look at it. Now, I remember when my class did this because I actually felt really sorry for them and felt like I hadn't really shown them enough questions like this. If you're anything like the students I teach, you'll be using the Pearson textbook, and the Pearson textbook is really very, very poor at showing enough questions on this topic. They just simply don't. So, go over those old M2 papers. Now, before I go through this, please, please, please do the question yourself. There's no point in just watching this video when you haven't looked at the question. You won't learn anything. You really won't. Anyway, let's have a go at it. So you've looked at this already. It's against a rough vertical wall, yeah? Well, that immediately means that you've got like two forces acting at A. You've got like a frictional force, which is going, opposite to oppose the direction of motion which the plank wants to fall, which is down, scraping down the wall. Imagine this is like like a wire kind of thing, and it's pulling this in. This wants to scrape down the wall, doesn't it? Because it's held against the rough vertical wall by a rope. Yeah, and so it's kind of scraping down. Now, the other force which is acting at A is a contact force, and these are both contact forces actually, but the normal reaction. And if you combine them, they'll be acting something like in that direction. But it's much easier to break them up into two things, yeah? Now, okay, so we've got that. A small block of mass 3m is operating on this. Now, the other thing I'd say is don't be lazy. Actually try out the diagram yourself. The diagram is most of the effort on these questions, but it makes things a lot easier if you've got a nice, clear diagram. Maybe it would have been easier. Actually, maybe I will keep doing it on theirs. But honestly, you're better off sort of owning the diagram yourself, and you want to get all the forces on it. Now, we've got F and we've got N here. This is of mass 3m. So this is going to be 3 capital MG. And then, of course, at the other end of A, and we're always showing the forces on the plank in these questions. It's all we're interested in. So I don't put a normal reaction force coming up on P here. Yeah, and that's just because we're not interested in the forces on P. There is a force on P of a reaction going up there, but we're not interested in the forces on P. We're only interested in the forces on the plank. And the last force we'll have is the tension in the rope pulling it up there. You have to have all those forces on this diagram or you're not going to be in a good position. The other thing we need to do is put the weight of the plank. The plank's bound to have a mass m. So that goes right in the middle. And this is why I would draw it out again, or it feels like I should, because that distance is x, whereas this distance here is a, because it's a uniform plank. I think it's modelled as a uniform. Yeah, I was guessing there really, and it's modelled as a uniform. Don't guess. Do read through this question. I've done this several times over the last few years, and so I'm hoping I get it right. But yeah, do read through it very carefully before you do a question. Okay, other thing is, tan alpha is 3/4. Immediately writing down what sine alpha and cos alpha is really, really useful. Probably the easiest way is to just draw a little diagram here. Recognise if that is alpha, then the opposite is 3, and the adjacent is 4. And therefore, we can now use Pythagoras to work that out as 5, because 3 squared plus 4 squared is 25, square rooted is 5. And now I can write down what sine alpha is. It's going to be 3/5, and cos alpha is going to be 4/5. This isn't the only type of mechanics question where you need to do that trick, so make sure you can do it. Now, this is all prep before we've even got near to showing this answer. Do you know what I mean? There's so much working to do. Now, we've got to show the tension in the rope, is that, yeah? Now, that immediately makes me think, well, okay, if I've got to find the tension in the rope, then I've got two choices here. It's either going to be about taking moments at A, or it's going to be about uppies equal downies, lefties equal righties. I think for this one, and I can't remember this question. It's been, a little while since I've done it. I'm doing this live. I think for this one, it will be best to take moments at A. Yeah, you will only ever have to take moments once in a question. I've never seen one where you have to take it twice. Actually, I tell a lie. There was a flat moments question once, which is about tilting at either end, where you did need to take moments twice, but it's extremely unusual. Yeah, so most of the time you're going to take moments once. Tell the examiner where you're taking moments from. That always helps. The reason why I'm thinking it's moments at A is because it knocks out these two forces, F and N. Yeah, and so you're left with just T, mg, and free mg involved, and that should surely help me find what T equals. Remember, this is T equals, so I want those letters still in the equation. Okay, so taking moments at A. Right. Whenever I take moments, I just picture this plank. Yeah, I actually get a pencil up to the screen. You may not see this right now, but I hold the pencil at where I'm taking the moment from, and I push in the direction of the arrows and see which way my pencil turns. And you will see that the plank for these two forces will turn in that direction. But for the tension, if you push the pencil holding it at A in that direction, it will turn up like that. And so we can see that these two forces are turning in a clockwise direction, whereas the tension will turn in anti-clockwise. Now, I prefer to just do clockwise moments equal anti-clockwise moments. So I'm going to do distance, which is A, times by force, which is mg, plus distance, which is x, times by force, which is free mg, equals distance, which is 2a, times by force. Now, be careful here because we need to resolve this force into a perpendicular component. That's the way I prefer to do my moments. I prefer to turn the force into a perpendicular component of the force, because that way I can just see, well, this, as that's going to be alpha up here, let's label this T, that's actually going to be T sine alpha at the top. Yeah, or you can look at it over here. That's going to be T sine alpha. So 2a T sine alpha. Get that done because that will be worth serious method marks. Yeah, no need to rush this. Okay, we can now simplify this and say this is mg 3x plus a on this side, and this is sine alpha, which is 3/5 times 2, which is 6/5 a t, times by 5, divide by 6a, and I reckon we'll have the answer. So we get 5 mg 3x plus a over 6a, and look at that, it's exactly their answer. That's a very difficult start to a question, though. When my class had to do this, I thought I was hoping for a simple ladder question because I knew that these were in the spec, but most of the time, on a lot of the old M2 past papers, the ladder questions were the most kind of common and also the most samey, and I thought they'd have mercy on them in the very first sitting because there weren't any past papers to go on. I was wrong. Yeah, they had no mercy. They are, yeah, not very nice in the mechanics or the stats paper. I think the applied papers are very, very difficult now. Okay, the magnitude of the horizontal component of the force exerted on the plank at A. Let's just think about what they mean there. The magnitude of the horizon component of the force exerted on the plank at A by the wall is 2 mg. What they're saying is N equals 2 mg. That's what they're saying. Yeah. So because we've got these two, I've basically broken the contact force here into its two components, a bit of friction going up and a bit of normal reaction, which is happening because the plank is pushing against the wall and so the wall is pushing back at the plank. So we can immediately say, in our way we've addressed this kind of problem, well, this means that N equals 2 mg. That's what they've told me. Yeah. And what I'm now going to do is I'm going to do lefties equal righties. Yeah. So what force is going to the right? N. What force is going to the left? Well, that's a T cos alpha. And so 2 mg equals T cos alpha. Was cos alpha 4/5 or 3/5? I can't remember. 4/5. And so I could say that this is the same as 10 mg over 4. But of course, that is 5 mg over 2. Now, look how stingy the marks are on this paper, because I've got to do all of that. And then to find x in terms of a, I'm going to have to equate this to this because I've got two expressions for tension now, so I can say, well, they must be the same. So 5 mg over 2 equals 5 mg 3x plus a over 6a. They definitely misjudged the difficulty of this question, if you ask me. I think it's very difficult. Cancel the 5 mg's. Do yourself a favour in this question. Make it easy for yourself. Times the 6a over here, so you get 3a equals 3x plus a. And what are we trying to put x in terms of a? So that's 2a is 3x, and so x is 2/3 of a. Okay, and that's done. X in terms of a. I think that's a lot of work, though, to get x in terms of a there. Okay, the force exerted on the plank at A by the wall acts in a direction which makes an angle beta with the horizontal. Now, what they're saying here is that if you combine these two forces, let's put F on the end of N here, because I think it almost looks nicer then. The force exerted on the plank by the wall is a combination of friction and normal reaction, and it makes an angle beta. Yeah. In other words, if I find the value of the friction and normal reaction, I could easily find the magnitude of the force which is being exerted on the plank by the wall. But it's saying it makes an angle beta. It's a difficult question, this, no doubt about it. Find the value of tan beta. Okay, right, we've got to find the value of tan beta. Well, we've done in these questions, right? One of the things you'll notice is you take moments and you do uppies equal downies and you do lefties equal righties. That's the number one thing you do in every wonky moment question. Wonky moments is basically take moments somewhere, then uppies equal downies and lefties equal righties. So what haven't we done yet? Well, we've taken moments, we've done lefties equal righties. What we haven't done is uppies equal downies. So let's do that. Yeah. So F plus, now what other forces are going up? You've got the T sine alpha, haven't you, going up? And that's going to equal 4 mg going down. So F plus T sine alpha equals 4 mg. Okay, and so F equals, now we know what T sine alpha is, don't we? Because didn't we have it before over here somewhere? T sine alpha, well, that's just T times 4/5, yeah, because this was sine alpha, wasn't it? And so T sine alpha is just 2 mg, yeah? So F is 4 mg minus 2 mg, which is 2 mg. Brilliant, yeah? And so how am I going to find tan beta? Well, I've got F now, and I've got N, yeah? Like, I've got them both. It's looking really, really, really good. And so, hang on a second. Let me just check I haven't missed out any forces here. F plus T sine alpha is 4 mg. That looks good to me. Brilliant. And so F is going to be equal to 2 mg. Have I made a little slip somewhere? Oh, sine alpha is actually, look at this, I've got this wrong. Sine alpha is actually 3/5. Why did I write down 4/5 there? Oh, because this was t cos alpha. I'm such an idiot. I'm so sorry. Look at that. I'm losing the thread of my own thought here. So let's get t sine alpha right first. Okay, what is t sine alpha? Well, if we look over here, we know that sine alpha is 3/5. So let's do this properly. Let's rub some of this out because that's wrong. Okay, so we've got f plus t times 3/5 equals 4 mg. Yeah, I was muddling up the sine alpha and the cos alpha there, so I apologise for that. And so F equals 4 mg minus, now for t here, we're going to have to really use, we could use 5 mg over 2. That looks like a sensible way to do it. So we'll do 5 mg over 2 times by 3/5. That's nice because 5's cancel, and we end up with 4 mg minus 3 mg over 2, which is, of course, 4 minus 1.5, which is 2.5 mg, or 5 mg over 2. Right, now we can work out what tan beta is. Because draw a little diagram again. You've got beta here. You've got F here, which is 5 mg over 2. You've got N here, which was 2 mg. And so tan beta is just going to be that one over that one. So we've got 5 mg over 2. Well, let's do it even nicer. You love a decimal, don't you? So we'll do 2.5 mg divided by 2 mg. The mg's cancel, and you're left with 5 over 4. And that's tan beta. Good. Phew. Almost made a mistake there reading the cos alpha as a sine alpha. That was pretty silly. So there we go. That's tan beta. That seems like generous for 5 marks. I don't like the way they've awarded the marks even in this question. It seems all wrong to me. Okay. The rope will break if the tension exceeds 5 mg. Explain how this will restrict the possible values of P. You must justify your answer carefully. Okay, well, with this, I'm going to go back to one of the expressions for T which has an X in it, yeah? Because tension is 5 mg, 3x plus A over 6A. And we need this to be less than or equal to 5 mg if you think about it, because we don't want the rope to break. Yeah, explain this will restrict the possible value of P. We don't want the rope to break. Well, we want this to be less than or equal to, because it has to exceed 5 mg, 5 mg. Yeah, brilliant. Now what we can do, so let's make that very clear that that's a 3x, is we can cancel the 5 mg's either side. Do that, that's now a 1, remember, and that's a 1. You've cancelled 5 mg. Make things easy for yourself in a question like this. So you've got 3x plus a is less than or equal to 6a. So 3x is less than or equal to 5a, and so x is less than or equal to 5a over 3. And that is the final answer. You can, it might be wise to explain. Yeah, we need the particle. They do like a concluding remark sometimes, to be less than 5a over 3 from a. Yeah, because it's measured from a, I think it was anyway. I hope so. There we go. Yeah, and there we go. So x must be less than or equal to 5a over 3. It can't go over that or the rope will break. Okay, I hope that question was useful. It is a difficult Wonky Moments question. I hope it was useful me going through it though, and keep up the hard work. Good luck in the A-level. Hope it goes well. Bye-bye.